Hi friends, welcome to my channel Interesting Engineering. Today let's discuss about laboratory type potentiometer, which is otherwise called a Crompton's potentiometer. So Crompton's potentiometer is a modified form of slide wire potentiometer and is used to measure unknown voltage by means of comparison with a known standard voltage source. As usual, this potentiometer is also meant for measuring unknown voltage values. So here, this is a modified version of slide wire. So slide wire potentiometer is the basic potentiometer arrangement and this is a modified version. So why we go for a modified version is there may be some sort of drawbacks in the basic arrangement that can be overcome by means of modified version. So let's discuss about what may be the drawback of the basic version and how it is being rectified in this type of potentiometer. So as we know, the slide wire potentiometer measures unknown voltage by means of movement of sliding contact over the slide wire arrangement. So the position of sliding contact in the slide wire represents the unknown voltage value. But when we want to measure higher values of voltage, we need to have a larger length of the slide wire arrangement. So when we go for larger length of slide wire arrangement, it creates problem. It creates a problem in the accuracy of measurement, precise value of measurement, and moreover, it also occupies a larger area which cannot be affordable in the case of laboratory measurements. So when we want to go for a laboratory measurement, we need to have a reduced length of the slide wire. So this reduced length of slide wire can be achieved in this Crompton potentiometer, and even though the length is being reduced here, the precision is being improved in this version. So we can even measure up to precisely up to 0.0005 volts. So that is the major advantage of this laboratory type potentiometer. So let's discuss about the constructional feature of this laboratory type potentiometer, and this is the structure of a Crompton potentiometer where we have this dial switch arrangement and the circular slide wire. So by means of this circular slide wire arrangement, we can able to measure precisely up to values up to 3 decimal points. So the length of the increased length of slide wire is being replaced by means of these two arrangements. So as usual, the potentiometers measures unknown voltage values. So this instrument is also going to measure the unknown voltage value, but its operation differs. So the movement of sliding contact, that medium only differs here, whereas all other things remains the same. So in any instrument, we need to calibrate the instrument first, and then we have to operate that instrument for a required purpose. So for our calibration, we have an arrangement here. So this is the double pole double throw switch, so which is positioned at two different positions. So one position, when it is placed at one position, it does meant for calibrating purpose, and when the switch is being thrown on the other position, other contact, we can able to measure unknown voltage value. So when we go for any potentiometer, the first thing we have to do is calibration, and then we have to go for operation, that is meant for measuring the unknown voltage. So here we have one more working battery. So this working battery is meant for providing a working current. So normally the working current in a potentiometer is maintained at 10 milliamps. So here the working current is maintained at 10 milliamps, and it is uh, achieved by means of this working battery, and this battery supplies current through this circuit, and the amount of current is maintained at 10 milliamperes by means of this rheostat arrangement. So by adjusting this rheostat arrangement, we can able to adjust the value of working current through this potentiometer circuit. So here we have a galvanometer arrangement. So this galvanometer is meant for providing the balance condition. So at balance condition, the galvanometer will be should be placed at zero position, null deflection position, and this galvanometer is connected by means of a protective resistance and a shorting key arrangement. So this protective resistance is meant for protecting the galvanometer from any damage due to overcurrent through this galvanometer. And here we have a standard cell. It is meant for calibration purpose. So for calibrating any instrument, we need a standard value. So that standard value of voltage is obtained by means of this standard cell arrangement. And here we have two terminal, and by means of these two terminal we can able to pass the unknown voltage, and it can be measured using this instrument. So this is about the construction of this Crompton potentiometer. And here one more thing, here we have a dial switch, and this dial switch has 15 resistors, and each resistor is have a value of 10 ohms each. So normally here we can able to measure up to 1.5 volts. So this circular slide wire, here too we have dial switch, that is a pointer arrangement which can be placed depending upon our requirement. So regarding its operation, initially this double pole double throw switch is placed at a single position, so which is nothing but the calibrate position. So when it is connected at the calibrate position, the standard cell comes into its operation. So the standard cell will be providing a standard voltage. Normally we pass a voltage of about 1.0186 volts, and for that voltage it is being entering into this circuit here. So the standard voltage of about 1.0186 volts enters this circuit, and that 1.86 volts is being established using this dial switch and the circular slide wire arrangement. So for to achieve 1.0186 volts, initially the dial switch is placed at 1 volts, and the circular slide wire arrangement, in this circular slide wire arrangement we place a voltage of about 0.0186 volts. So totally we could obtain up to 1.0186 volts. So by varying the position of these two pointers over this dial switch and this circular slide wire arrangement, the galvanometer is checked for its null balance condition. So at that position the key is being shorted. So initially the entire circuit comes into its operation under a calibrated position. So the amount of voltage entering here is being positioned by means of these two switches, and at that case we can able to standardize this instrument. Then after standardizing the instrument, we pass the unknown voltage through these two terminals, and at that condition the double pole double throw switch is being placed at these two positions. So it is being placed at operate positions. So when it is placed at operate position, the unknown voltage enters over here. So for the position of this dial switch and circular slider arrangement, it is being adjusted, the galvanometer. It is being adjusted, the entire position of these two pointer is being adjusted for the unknown voltage. So while adjusting, the galvanometer is checked for zero null balance condition. So when this when the position of these two pointer matches with the unknown voltage, the galvanometer shows null deflection. At that position, that position of the pointers represents the measure of unknown voltage. This is how the potentiometer operates. So the unknown voltage enters over here. So for that unknown voltage, the pointers in these two dial switch and circular slide wire is being adjusted. So while adjusting it, the galvanometer is checked for null deflection. So when the galvanometer reaches null deflection, the position of these two pointer represents the amount of unknown voltage entering through the circuit. So by means of which we can able to measure the amount of unknown voltage entering the circuit. So this is about the operation of this potentiometer circuit. So while measuring, we need to check its accuracy once again. So while for checking the accuracy, once again the key, the double pole double throw switch is placed at the calibrate position and it is being checked again for the position of these two dial switches. So this is about the Crompton potentiometer, and in our next video we shall discuss about AC potentiometer. For more videos, keep watching. Please subscribe and share. Thanks for watching.